Hello, this is Mr. Mac. This is a video to explain the solutions to the problem sets on session 1. Question 1, find the complement of each set. Each of the following sets given the universal set is the set of positive integers less than or equal to 20. Okay, so we need complements. Now, if U is the set of positive integers less than or equal to 20, it starts at 1, 2, 3, and it ends up at 20. So a complement in this first one is going to be not 1, not 2, 3, 4, 5, 6, 7, 8. It's going to be 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now, if A is the set of prime numbers less than 20, a complement there, let me just make this, no, we don't want to do that. Maybe we can grab it this way. There we go. Make it a little bit smaller. Okay, if A is the set of prime numbers less than 20, then a complement would be 1, because a complement is the set of numbers that positive integers less than or equal to 20 that aren't prime. And 1 isn't prime, 2 is, 3 is, 4 isn't, 5 is, 6 isn't, 7 is, 8 isn't, 9 isn't, 10 isn't, 11 is, 12 isn't, 13 is, 14 isn't, 15 isn't, 16 isn't, 17 is, 18 isn't, 19 is. Now, 20 isn't prime, but 20 is in U, and even though A is the set of prime numbers less than 20, 20 is going to be in the complement because it is in the universal set and it's not in set A. All right. For C, B is the set of numbers B is the set of even numbers less than or equal to 16. So B complement is the set of odd numbers starting with 1, 2, 3. Up. 2's not in there. 2's even. So 1, 3, 5, 7, 9, 11, 13, 15. Now, less than or equal to 16. Now, 16 is in B, so 16 wouldn't be in the complement of B. 17 is in B. Now, 18 in B complement. 18 is in B complement because it's not in B. 19 and 20. Okay, so the set of B complement would be this set. Now, if a number isn't prime, we say it's composite, but 1 is neither prime nor composite. So on D, C is the set of composite numbers less than 20. So C complement would, even though 1 isn't prime, it's also not composite, so it gets to be in C. So we want, actually, other than 1, we want the primes 2, 3, 5, 7, 11, 13, 17, and 19. So that would take care of number 1. Now I'm going to erase these things so I'll have enough room for problem number 2. Number 2, find the intersection of A and B if A is the set 2, 3, 4, and B is the set 1, 2, 5, 6. Well, A intersect B will be the set of elements that are in both A and B, and that would be 2. For Part B, A intersect B, will be the set of elements that are in both 4, 8, and 12, and 3, 4, 5, 6, 7. So 4 is in both, and that's it, the set 4. Now C, A is the set of factors of 36, and B is the square numbers less than 10. Okay, so I'm going to be asked a question, so I'm going to pause this here. Okay, back to work. A is the set of factors of 36. Well, let's just list the factors of 36. 1, 2, 3, 4, 6, 9, 12, 18, and 36. B is the square numbers less than 10. So B is 1, 4, 9. So the intersection of A and B is the set 1, 4, 9. All right. On to union. Find the union of A and B if A is the set 2, 3, 4, and B is the set 1, 2, 3, 5, 6. Well, A union B will simply be the set 1, 2, 3, 4, 5, 6. B, find the union if A is 4, 8, 12 and B is 3, 4, 5, 6, 7. So A union B will be 3, 4, 5, 6, 7, 8, and 12. To get the union again, what you do is you just pour everything into the union that's in either set. And C, A is the set of factors of 36, and B is the square numbers less than 10. Okay, now remember up here, A intersect B was just set B, so A union B is going to be, actually it's going to be the set A, 1, 2, 3, 4, 6, 9, 12, 18, 36. Because the set of square numbers less than 10 is 1, 4, and 9, and so we would put those in the set. They're already there from A, so A union B is the same thing as set A. All right. Number 4. A small college has 1,000 students. F is the set of freshmen. M is the set of music majors. The Venn diagram below displays these sets. Describe the following sets in words and tell how many members it has. Okay. All right. F intersect M. Now, first of all, F intersect M would be this region right here, and there's 15 members in that set, and that would be the freshmen that are music majors. I'm not going to write it, I'm just going to say it to you. It's the freshmen that are music majors, or the students that are both freshmen and music majors. Now, part B, FUM. Now, that would be this set here, and it would have 285 plus 15, that's 300. It would have 350 members in it, and FUM is the set of freshmen or music majors, students that are freshmen or music majors, or both. Now, C, not F, or the complement of F. That would be students that are not freshmen, and that would actually be, oops, that would actually be this set right here. And so that would be, there would be 700 in that set. And that would be the set of students that are not freshmen. No, I don't want to move that one. I want to move this one. Now, not M would be, actually, these two. 650 plus 285 is, there's a 5, there's a 3, and there's a 9. 935, and this would be the set of students that are not music majors. And, okay. Now, not F intersect M. Now that would be everything outside of F intersected with everything that is inside M, and that would just end up being this one right here. So we would get 50 members in not F intersect M. And that would be the set of students that are music majors and not freshmen. And then finally, F union not M. So that one would be everything that is in F unioned with everything that was outside of M. So it would be this 285, this 15. Now, yes, those 15 are in M, so they wouldn't be in the not M, but they get to be in the union because they're in F, and then the 650. So we would actually have 950 in this set, and that would be all the students except the non-freshman music majors. Okay. Moving on, it says problems 5 and 10, 5 through 10, draw a Venn diagram to illustrate each situation described, then use the diagram to answer the questions asked. Okay. In 5, in an election day survey of 100 voters leaving the polls, 52 said they voted for Proposition 1, and 38 said they voted for Proposition 2. If 18 said they voted for both, how many voted for neither? All right, well, let's do this. Let's just come up with a little rectangle here that we can use to cover up some things so we've got some room to write. All right, now we have as our universal set the 100 voters that were surveyed. Now, 52 said they voted for Prop 1. And 38 said they voted for Prop 2. Now, 18 said they voted for both, so we've got 18 here. Now, if there's 18 here and a total of 38 in the Prop 2 set, then we've got 20 more in this region. And if there's 18 in the intersection and we have a total of 52 who said they voted for Proposition 1, we're going to get, what is that, 34, I think, more here. Now, if we add these up, 34 plus 18 is 52. 52 plus 20 is 72. So there's going to be 28 of the 100 voters that aren't inside either circle. And so then the question is, how many voted for neither? Well, the answer is this 28 here. All right, we're going to move on to question number 6. And you say, but Mr. McFarland, how are we going to do that? Question number 6 is covered up. Well, maybe we can just uncover it. There we go. Number 6, although the weather was perfect for the beach party, 17 of the 30 people attending got a sunburn, and 25 of the people were bitten by mosquitoes. If 12 people were both bitten and sunburned, How many had neither affliction? All right. Well, once again, the universal set is going to be 30 people who attended the beach party. Now, some of them were sunburned. I'm just going to use SB. And some of them were mosquito bitten. I'm going to use MB for that. Now, it turns out that 12 people were both bitten and sunburned, so we put 12 in the intersection of sunburned and mosquito bitten. Now, 25 were bitten by mosquitoes, so that would be 13 more in this region here. That looks an awful lot like a B. Let me see if I can write that 13 better. Yeah, there we go. And 17 were sunburned. That means there's 5 more in here. Now, if we add 12 and 13, we get 25 plus 5 is 30. So there are no people in the universal set that aren't inside one of the circles. So it turns out that everybody was afflicted at least once at this party. Doesn't sound like that good a party, to tell you the truth, but they probably had a good time. Okay, going on to question number 7. We're going to do the same thing we just did a moment or two ago. Slide down a little bit and get question number 7. In a survey of 48 high school students, 20 liked classical music, 16 liked jazz. 20 students said they didn't like either. How many like classical but not jazz? All right, here is the 48 students. And here is the set of classical music lovers, and here's the set of jazz lovers. Now, in this case, they're telling us that 20 don't like either. So we need to figure out the others in here. So now, if there are a total of 48 students and 20 like neither type of music, then 48 minus 20, or 28, is the number of students in the classical music union jazz likers. Now we know that the number of students in classical music union jazz lovers is equal to, now let's do this. Let's let this be X. Then this would be 20 minus X, and this would be 16 minus X. And we know that 20 minus X plus 16 minus X is going to be equal to 28. So 20 plus 16 is 36. Minus X plus X minus X becomes minus X equals 28. Probably the easiest way to solve this is to just subtract 36 from both sides. We get negative X equals, I think, negative 8. So X equals 8. And once we know X is 8, we know that 20 minus 8 is 12. And we know that 16 minus 8 is 8. Now let's stop for just a second and check to make sure this makes sense. If we add 20 and 12, that's 32. And 8, that's 40, and 8 more is 48. So it does check. So how many like classical but not jazz? Classical but not jazz is this 12 here. All right. Question number 8. Of the 52 teachers at SPHS, 27 said they like to go boating, 25 said they like to go fishing, and 12 said that they didn't enjoy either recreation. How many enjoy fishing but not boating? This one's very like number 7. If you were having trouble with 7 before and now you understood it, you might want to pause this video at this point and try number 8, because it's the same question really as question number 7. Okay, welcome back. Here is the Venn diagram. We have 52 teachers, and we've got some that like to boat, and we like some that like to fish. Now, there are 12 that don't enjoy either, so let's let this be X. Let's see, how many like boating? 27. So this is 27 minus X. And how many like fishing? 25. 25 minus X. And we know that the total number of teachers that are inside these two circles is 52 minus 12, or 40. So 40 is going to be equal to 27 minus X plus 25 minus X. So we get 40 is equal to, now this is 52 minus X plus X minus X is minus X. So if I subtract 52 from both sides, I get negative 12 equals negative X, so X equals 12. How strange. We have no, the 12 is not the answer. That's how many like both. The question is, how many enjoy fishing but not boating? That would be 25 minus 12, or 13. So 13 is going to be the answer here. Always make sure that you're answering the question that's asked, not some other silly question that you make up in your own head. All right. Went down a little too far there. 9. A parking lot contains 85 cars. There are 45 cars with automatic transmissions, 43 with rear-wheel drive, and 46 cars with 4-cylinder engines. Okay, now in this particular case, we've got 3 different sets in our Venn diagram, so we're going to have 3 overlapping circles. And I think my rectangle is going to need to be a little bit bigger. All right, here we go. Our Venn diagram. There's 85 cars. Now, we've got automatic transmission, AT. We have rear-wheel drive, RD. And we have 4-cylinder, 4C. Now, they give us a lot of information. 26 of the cars with automatic transmissions, 26 also have rear-wheel drive. Of the cars with rear-wheel drive, 29 also have 4-cylinder engines. Of the cars with 4-cylinder engines, 27 also have automatic transmissions. There are 21 cars with all 3 features. So we'll start with the 21, and it goes right here. That's the overlap of all 3 circles. Now, let's see if we can unravel some of this. Of the cars with 4-cylinder engines, 27 also have automatic transmissions. So this region right here is the region of 4-cylinder cars that also have automatic transmissions, and there's supposed to be 27 in that region, so there's going to be a 6 here. Now let me just move this out of the way. I might be able to use it again, so let's just hang on to it for a second. Let's see, of the cars with, of the cars with rear-wheel drive, 29 also have 4-cylinder engines. So this region right here has a total of 29 in it, because it says of the cars with rear-wheel drive, 29 also have four-cylinder engines. So there's 21 in there. That means there's going to be 8 more in this region here to make a total of 29. And then it says, of the cars with automatic transmissions, 26 also have rear-wheel drive. So now this region right here is going to have 26 in it. We've got 21 in there already, so we have 5 more right here. Now we're finished with this. I'll move it out of the way. So now let's finish the rest up. There's 45 cars with automatic transmission. If you look at the circle of automatic transmission, we already have, we already have 6 plus 21 plus 5. That's 32. There's a total of 45, so 13 more go here. 43 cars have rear-wheel drive. We already have 5 plus 21, that's 26, plus 8, that's 34 in there, and 43 makes, I believe, 9 more here. And then there's 46 cars with four-cylinder engines. Now we have 6 plus 21, that's 27, plus 8, that's 33. So for 46, I believe there's 13 more. I sure hope I haven't made a mathematical mistake here, but if I have, I told you how we was getting the numbers and just put the right number in. Now we have a total of 85 cars, and in this particular case, I think it'd probably be best for me to just use a calculator to add all of these things up. So we've got 13 plus 5 plus 9 plus 6 plus 21 plus 8 plus 13 gives us 75, which means I believe there's 10 in this region here. Now I think we're ready to answer the questions. How many cars do not have automatic transmissions and rear-wheel drive, but do have four-cylinder engines? Now that would be, let's use blue here. That would be this region right here. They're inside the four-cylinder engines, but they're outside automatic transmission and rear-wheel drive. So the answer to that one would be 13. And then it says how many cars do not have any of these features. That's the set that's out. That's the cars that are outside all 3 of these, and that would be 10. All right. Number 10. Of the 415 girls at Gorham High School last year, 100 played fall sports, 98 played winter sports, 96 played spring sports, and 22 played sports all 3 seasons, while 40 played only in fall, 47 only in winter, 33 only in spring, 13 played only fall and winter. Okay, now that's probably enough for us to fill in all of the numbers in the Venn diagram. Let's give it a try. Now, what have we got here? We've got 415 girls at Gorham High. I'm just going to put girls here. 415 girls. Now, we've got fall sports. We've got winter sports. And we've got spring sports. Now, 13 played, let's see, 30, let's see, do we have 22 played sports in all 3 seasons, so we'll start here with 22. Now, 13 played only fall and winter. Okay, so 13 played in the fall and winter, but not in the spring. that would be this particular spot right here. 33, let's see, 33 only, okay, let's do this. 22 played sports all 3 seasons. 40 played only in fall. So 40 played only in fall, that's this region here. 47 only in winter, that's this region here. 33 only in spring, that's here. 13 played only fall and winter, that's there. Now, I think we can figure out these other regions because we know, for example, that in the fall, 100 played. Now, if we add 40 and 13, that's 53. 75 is what we have inside the fall circle already, so there's another 25 that go here. Now, in the winter, 98 played sports, so already we add 47 and 13, that's 60. We get plus 22 is 82. 98 minus 82 is 16, so we have 16 more here. Now, again, I'm going to just wimp out and use the calculator to find the number that are outside. Where's my calculator? Okay, I'm going to have to start my calculator up again. I pressed something wrong. I'm going to use the calculator, though. I think it'll be faster. So we move this over here, and now what do we have? We have 40 plus 13 plus 47 plus 25 plus 22 plus 16 plus 33 is a total of 196. Now, if we subtract 196 from 415, we're going to get 219, so there's a 219 here. All right, and now for the questions. How many girls played fall and winter sports, but not spring sports? Fall and winter, but not spring. Oh, that one's right in there. 13. It's this region here. Fall and winter, but not spring. How many girls did not play sports in any of the 3 seasons? 219. So we have 13 here. 219 there. Yeah, we couldn't have answered B without doing all this work, but A, we could have answered if we just looked back up at the question. All right. Moving right along. Number 11. May has applied to both Harvard and the University of Florida. She thinks the probability that Harvard will admit her is 0.4. The probability that Florida will admit her is 0.5. And the probability that both will admit her is 0.2. Make a Venn diagram with the probabilities given marked. What is the probability that neither university admits May? What's the probability that she gets into Florida but not Harvard? All right. Here's Harvard. Here's Florida. Now, she believes that both will admit her as 0.2, so we can put a 0.2 in the intersection. Now, if she believes, and if we accept her belief here, that Harvard will admit her as at a probability of 0.4, there's another 0.2 here. And if Florida will admit her at a probability of 0.5, there's a 0.3 here. Now, if we add these up, we get 0.7, so there's a 0.3 out here. So, what is the probability neither university admits May? That's this 0.3 here. What is the probability she gets into Florida but not Harvard? That's this 0.3 right here. And we're done. Okay, well, we're finished with this problem, but we're not finished with the homeworks yet. Okay, moving on down to number 12. Okay, consider the following experiment. Letters in the word aardvark are printed on a square piece of tagboard, same size squares, with one letter per card. The 8-letter cards are then placed in a hat, and one letter card is randomly chosen without looking from the hat. V is the event the letter chosen is a vowel. F is the event the letter chosen falls in the first half of the alphabet, i.e. between A and M. So between A and M, aardvark? M? Well, let's just take the verbal description here. The letter falls in the first half of the alphabet. Okay. So letters in the first half of the alphabet in aardvark are A, D, A, K. 1, 2, 3, 4, 5. So 5 of the cards are in the first half of the alphabet. Okay, now it says list the outcomes in each of the following events and determine their probabilities. Okay, V, the letter chosen would be a vowel. The outcomes are A, A, A. And I think we have to list those 3 times because we have 3 different cards with an A on them. Okay, now F, that would be A, D, A, K. V or F. Now, or means union, so the union of V and F would be A, D, A, K. The complement of F would be R, V, R. The probability of V would be 3/8. We put the number of successes on the top and the number of cards on the bottom. The probability of F would be 5/8. And since V or F is the same as F, that would be 5/8 as well. The probability of F complement would be 3/8. The probability of F and V would be V, actually, which would be 3/8 again. And we're finished with that one. All right. Now, 13. Out of 80 workers surveyed at a company, 17 walked to work. Is the ratio of the number of times an event occurs, experimental probability, is the ratio of the number of times an event occurs to the total number of trials or times the activity is performed. What is the experimental probability that a randomly selected worker at the company walks to work? Well, the reason we say experimental probability here is it says out of 80 workers surveyed at a company, 17 walk to work. Now that doesn't mean that the company has 80 workers. They probably have a lot more than that. But what we're going to do is we're going to infer the probability of the actual probability of workers at the company by using this survey of the 80 workers. So we call it an experimental probability. Of our 80 trials, we found 17 times that worked, so that would be 17 over 80 would be the experimental probability that a randomly selected worker at the company walks to work. Predict how many of the 3,600 workers at the company will walk to work. Well, that's really pretty easy. The ratio of walking to work to worker is 17 over 80. So 17 is to 80. as X walkers is to 3,600. Now this equation simply becomes 17 over 80 times 3,600, which is, wait for it, 17 divide 80, oops, not 8.80, times 3600. And we get 765. So we're going to predict that 765 of the 3,600 workers actually walk to work. Okay. We're going to have to erase this. Mr. and Mrs. Smith each bought 10 raffle tickets. Each of their 3 children bought 4 tickets. If 4,280 tickets were sold in all, what is the probability that the grand prize winner is? Now, there is only going to be one grand prize winner. That's kind of inherent in the term grand prize winner. In raffles, you can have subsidiary winners or whatever you want to call them, but there's only one that wins the grand prize. That's kind of the draw of a lottery or a raffle. So Mr. and Mrs. Smith bought 10 raffle tickets. So they have 10 chances to win the raffle out of the 4,280 tickets sold. So it would be 10 over 4,280, which simplifies to 1 over 428. Now, what's the probability that one of the 5 Smiths won the grand prize? Well, what we have to do there is figure out how many raffle tickets the Smiths hold. That's 10 for the parents, and then 3 times 4 for each of the children. And does that make 5 Smiths? Well, Mr. and Mrs. Smith is 2, and then 3 children is 5. So we get 10 plus 3 times 4 over, again, 4,280. So that's 22 over 4,280, which reduces to 11 over 2,140. Now, what is the probability that none of the Smiths win the grand prize? Well, the probability that none of the Smiths win the grand prize is 1 minus the probability that one of the Smiths do win the grand prize. So we're just going to have 2,129 over 2,140. See, because this becomes 2,140 over 2,140, and then you subtract 11 from the numerator, and you get 2,129 over 2,140. So it is much more likely that the Smiths will not win the grand prize than that they will win the grand prize. All right, moving on. We have, what do we got next? We have number 15. Okay, now 15 in New York City is divided into 5 boroughs: Manhattan, Queens, Bronx, Brooklyn, and Staten Island. Suppose that a New York City telephone number is randomly chosen. Explain why the probability that it is a Manhattan telephone number is not 1/5. Well, see, if we select a number randomly, then we're going to get the probability that that one is chosen is 1 over the total number of telephone numbers. Now, the total number of telephone numbers would be the sum of the telephone numbers in Manhattan and in Queens and in the Bronx and Brooklyn and Staten Island. But if there aren't the same number of phones in each of these areas, then it's not going to be 1/5, because there can be different numbers of phones in these different boroughs. In fact, there would almost definitely have to be it would be really strange to have it work out so that they were all exactly the same number in each borough. What do you need to know in order to find the correct probability in part A? Well, you need to know how many phones in each borough Now, you'd also like them to tell you the total number of phones, but if you knew how many phones there were in each borough, you could add them up to get the total number of phones in New York. All right, number 16. The probability you watch TV is 55%. Oh, let's get rid of this here. The probability you watch TV is 55%. The probability you will talk on your cell phone is 65%. And the probability you will watch TV and talk on your cell phone at the same time is 30%. Find the probability you will watch TV or talk on your cell phone. Okay, here we go. Here's watch TV. Here's cell phone. Now, the probability you do both is 30%. I'm just going to put a 0.3 there. The probability you watch TV is 55%, 0.55. So we've got a 0.25 here. The probability you talk on your cell phone is 0.65. So you've got a 0.35 here. Now, if you add these all up, you get 0.95. So there's 0.1 down here. Okay, find the probability you will watch TV or talk on your cell phone. Now, or here is not exclusive. That means one or the other or both. And so that would be the sum of these three, which would be 90% or 0.9. All right. Number 17. Surely we got to be getting to the end of this pretty soon here. Yeah, I think 17 may be the last one. Okay. During the random selection of a calendar year, it was found that the probability a person is born on Tuesday is, I think that's, gosh, 52 over, no, that's a 53. I'm going to say it's 53 over 366. The probability a person is born on the first day of the month is 12 over 366. That makes sense. The probability a person is born on a Tuesday, the first, in other words, this one is the intersection of the first and second, is 2 over 366. Find the probability a person is born on Tuesday or on the first day of the month. Okay, well, the probability Tuesday or first day of the month is a union, and that's equal to the probability Tuesday plus the probability first day of the month minus the probability Tuesday and first day of the month. This is the principle of inclusion-exclusion. So we get probability Tuesday is 53 over 366. Probability first day of the month is 12 over 366. And minus probability Tuesday and first day of the month, that's 2 over 366. So that ends up being 53 plus 12 minus 2, or 63 over 366. And we've been waiting a long time for me to say this, and we're done.